Hi, good morning. How's everyone today? Good? Excellent. So first of all, thank you so much for joining us today. Before we start the session, think about that you are a chef and you want to prepare a dish for your friend because it's his birthday. As a chef, you have the end goal in mind, which is the dish that your friend likes. But through the course of preparation, there are so many steps involved. You have to get good quality food, the spices, the temperature needs to be right, and you have to put the ingredients in the right order, and finally, there is a dish that your friend likes. So when we think about data engineering, it's nothing different. You have the end goal in mind to build a scalable, reliable data pipeline with quality that serves your business use case so you can make the decision at the right time. But with data pipeline, there are so many steps involved. You need to catalog the data, you need to profile the data, and then you have to build the jobs, you have to orchestrate it, you have to deploy it in production, and then provide it to the end users for reporting or to serve them. But what if, through each of those steps, there is an agent which works as a pair programmer for you? So this is our session today to walk you through agentic data engineering using AWS Analytical MCP Servers. I'm Harshida Patel, a Principal Specialist Solution Architect from AWS, and joining me today is Ram Notat, who is a Principal Solutions Architect with Data and AI. Okay, thank you so much, Ram. So this is our journey for this session. We'll start off with the data engineers' pain points and the challenges they run into, followed by using agentic AI as the solution with model context protocol. Then we'll do a demo, share with you best practices and how you can deploy this in production at scale and share resources that you can walk away with. So let's get started with Meet Any Company, which is a fictitious retailer. They want to transform their business by transforming their customer experience by tapping into the data. They have a very clear vision and a mission that they want to put data to work and make an impact. So they start off with a solid data strategy where data is the foundation. They want to build scalable analytical pipelines with quality to serve their growing use cases. But their main goal is to provide this insight into the hands of the decision maker at the right time so they can make a data-driven decision. So this is their vision and their mission. But when we check the reality, it's completely different. A marketing team reaches out to the data engineers and say, this is a new promotional analysis that we want to build and get insight into. Can you build a data pipeline for this? They say it's going to take 2 to 3 weeks. The operational team wants to get near real-time insight into the inventory. The data engineer shares, our data pipeline is already lagging 3 to 5 days. The executives want to automate the Monday morning report so they can make the decisions at the right time. But it's still a manual refresh. So this is impacting the marketing team, the operations teams, the executives. So the bottom line, it's impacting the revenue because the decisions cannot be made on time. When you further deep dive into and ask the data engineers, what is the cause for this productivity or what is the cause for these delays? And I would love to ask you a question, does any of this resonate with any of you? Right? Context switching starting with number 1. So when you get the data engineers get the requirement, they want to embed a new feature within their product. So they search through the code, they try to understand the code, there is no documentation. Once they understand the requirement, they go and do web search to figure out the best practices, to write the code, figure out how this particular feature in AWS really works. Then they start developing the code, writing things from scratch. And while they are writing and focusing on the development, There is a data analyst which sends an alert that the key performance indicators for today are completely off. So they start debugging, they start looking at the data, and they finally figure out, after hours of effort, that there is a source data quality issue. So we missed an entry in the dimension, so when you're joining to the fact, it's not able to relay the key performance indicator metrics. So again, data quality is more reactive. It's not proactive. They go back, once the data is fixed, they go back to do the development, but then there is an alert that the data pipeline today is very slow. It's not performing. So again, the data engineer switches the focus, figures out what the performance issues are, and then tries to go to the web search, how do you optimize this pipeline? And this is where the time gets lost. So all of these things are piling up. Then one fine day, Sarah Chen, who is the CTO of data engineering, sends an email that we are missing to provide the data insights to the marketing team, the operations team, as well as the executive team. Sarah heard from one of her friends at another retailer that they are able to see productivity gain while building the data pipeline using data engineers, using Agentic AI. So Sarah asked the team whether we continue to do something which is not working or radically shift the direction. So let's work backwards from what the ask is and see what is possible. Let's use this use case of a traditional data engineering versus with agentic data engineering. So let's go back that the developer or the data engineer got the requirement, find the retail customer data set, process it, check the demographics, validate it, and made and upload it to a data warehouse for reporting. So what does a data engineer do? If the data set is catalog, they would go to the catalog, they would search the location, they will be able to find out the column, the corresponding data type. Once they have identified, they start writing the code from scratch, they deploy it, they run it. If there is an error, they fix it. Then they write a SQL to validate that data set just to look at, are there any null values? Are there 50 states in the data set? Then they write a Python code to load this into a data warehouse. Versus with agentic data engineering, what if for each of the steps, instead of writing and typing and going through the console, it's converted into a natural language? So first, find the retail customer data set. Once you find it, create a glue job, deploy it. If there are errors, you fix it, you validate the data set, and then you finally load it to a data warehouse. So the manual process of clicking through, converting that through agentic data engineering by asking questions in the natural language and have the agent do the work on your behalf. So how is this possible? This is where the agentic loop comes into play, where you have an agent, where we exactly ask the same question for the retail customer data set, process it, validate it, and upload it to a data warehouse. This is your question. Your question becomes the goal for the agent. It has cognitive insight. So as a data engineer, once we get the requirement, we try to understand it. We try to plan it. We try to take action. Then once the action is performed, we try to make decisions. So all of this is the reasoning. And while the large language model takes your request, parses out into multiple steps, it also needs information. So it's able to identify, I need more data to get more context to figure out what my next course of action should be. So the agents have access to the tools where they can execute not only a code, but also retrieve more information. And this context goes back to the LLM, where it's able to see, get, and perceive from the new information it got, and then figures out what next step it has to take. So this loop of reasoning, as well as taking the action till your goal is met is what is the agentic loop. Now let's dive into the building blocks with the agentic AI. So agent is in the center. Agent has memory. It has short-term and long-term memory. The short-term memory is for in the context of your session. The long-term memory, think of it as episodic, what happened in the past, like your personal diary. It can also have semantic memory, where it has the context of your domain or domain-level knowledge. The agents has an arm, where it has access to tools. And the tools are something that you control. Whether you want to have a function for the agent to access your data, your AWS services, and this could also be external services. So tools is the action that the agent can take. It's calling a function. The function can be retrieve the data, run a code, or invoke an API. So that's the action. The agent has brain. So we talked about reasoning. The next step is it identifies multiple steps that it needs to take to solve a complex problem. It takes a step, it gets the insight and the results from the tool, then it reflects what should be the next course of action. So the planning, reflection, chain of thoughts, as well as self-critiquing. The main thing is action. And this is also what you control. Whether you want all the actions to be on autopilot or you want the human in the loop for some of the actions. So an agent, along with the memory, the planning, the reasoning, along with the tool, is what it automates and independently works to perform the task that you provide, which is the goal for the agent. And for an agent, give it a persona. So for our talk today, we'll give it the persona of a data engineer. The goal is to build a data pipeline and provide the instructions precisely so it can think better. Now, let's summarize all of this. So we talk about agentic loop, we talked about the building blocks, but now let's put a simple example of a workflow. So you as a data engineer, you're asking a question to build the pipeline in natural language. Your interaction is with the agentic assistant, and then the agentic assistant is already integrating with the tools, your data sources. So along with this question, the tool descriptions are sent to the large language model. The large language model, as it has parsed out your complex question into multiple steps, it decides whether it wants a specific tool or to do a function call. So it makes the request back to the agentic assistant along with, so that it can get the context. The agentic assistant invokes the function to retrieve the information from your data source. It gets the results, and these results are sent back to the large language model. Now, large language model gets that information of the results, context, it's going to reflect, it's going to figure out what is going to be the next course of action. In our use case, we started off with retail data, customer data set, which is on S3. So it's going to request, find me the location of retail customer data set. The tool is going to call, whether it's list S3, or whether if they are using data zone, it will invoke an API for data zone. The agent calls that tool, performs that function, the results are returned, and that information that, hey, this is the location of the S3 data set is sent back to large language model. But the next step, we need to create a glue job. So the large language model is going to call another set of function. So this entire loop is dynamic in nature. This loop is going to continue until and unless it has all the information to meet your goal and provide a final comprehensive response to the end user. So we saw that we have agents, but the agents just with large language model is not enough. It needs to have the context. It needs to have the information. It needs to perform an action. So the integration of the AI agents with the tools and the data sources becomes important. So why is this a little bit challenging to integrate the data sources and the tool with an AI agent? Let's consider this use case. You have an AI agent. When you need to talk to a data warehouse, it uses SQL. When it needs to talk to, say, a Glue catalog, or it needs to do data processing, it's going to use API. What if there are specification changes? Then they have to update the specification to adhere to the API. What if they need to add another tool or remove a tool? And this might be simple if you have one agent, but when you start creating n number of agents, think about the tight coupling and the integration problem, and this is all custom integration. This is n times m custom integration problem. So how do we simplify this? How do we make it seamless for the AI agents to discover what are the data sources and what are the tools which are available? This is where Model Context Protocol comes into play. It's a universal language. So in this example, you want to add a tool, you add a function. If you want to remove a function, you remove the function from MCP. If there is an API change, you make that change in one single place. Then you can integrate one agent, or you can integrate n number of agents. So this makes the integration standardized integration. So what is Model Context Protocol? It's USB-C for agentic AI applications. And this was invented or developed by Anthropic. So let's look at the architecture for MCP. There is MCP host, the one with which you are integrating. There is an application. You can use an application of your choice. It could be Amazon SageMaker Unified Studio, Kiro, Claude Desktop, and those application needs to be MCP compliant. So there is the client side, and these clients are integrating or communicating with the MCP servers. And this integration from the client to the server is known as the transport layer or communication model. There are two deployments of MCP servers. When the MCP server is locally deployed, where it's using the compute of where your host is, that is the local deployment of MCP server. And the communication it uses is standard input-output. If the MCP server is remote, it's going to use HTTPS. Now the server is the one that is integrating with your data sources, your data, which is in your control. So the way the MCP server integrates with the data sources, it could be SQL, it could be API, it's completely independent depending upon the services that it provides. So let's take over here as an example. Say you're working with Kiro. I'm going to use Kiro because it's been announced even yesterday with a lot of features. You ask your question, find the same question, right? We are going to repeat throughout the talk, is find me the retail customer data set, process it, validate it, and then load it into the data warehouse. The large language model, think about it, it's going to break it down into multiple steps. For the first step, it's going to, and then because of this integration of MCP client, it also has the information of the tools that it can use. So the first step is find the data set retail customer data. The tool it wants to use is list S3, or if there is a data catalog, go through and search through the data catalog. So the client sends that request to the server. The server is the one that is running the function to integrate with your service. Then the response is sent back from the server to the client and to the large language model, enriching the context, and it figures out the next step. So what are the components on the server side? There are three components: tools, consider it, not consider, it is the functions that the client can call. For example, create a Glue crawler or create a Glue job, for example. Resources are read-only, get me the list of all the Glue tables, and then you have prompts, which are blueprints or structured prompt templates. If you want to take a picture, I'll go a slide back. Okay. So now we talked about how agentic AI, which is the reasoning and the action and the loop and the integration with the tools going to help work independently to serve a data engineer to perform the tasks. The MCP servers when you have an analytical tech stack where you could be using multiple services, AWS Glue or Amazon EMR or Amazon Athena or Amazon Redshift, this MCP servers, AWS Analytical MCP Servers, think about the first problem that the developers had, context switching. This MCP servers covers multiple services. The second is getting the latest and the greatest information on the features, the best practices. So when the data engineer asks a question, build me a code, that code will be with quality because it is aware of the best practices. When you're trying to build a workflow, process the Glue job, and then load this data into a data warehouse, it's like workflow orchestration. So it has the domain knowledge of the AWS services to work with. So the MCP servers with AWS is when you're using Amazon Glue, AWS Glue or Amazon EMR for your data processing, or Amazon Athena for interactive query, there is data processing MCP server. And the questions a data engineer you can ask, create a Glue crawler. And these are only few list of questions in the list. We'll also share with you a QR code where you can find the entire list of MCP servers along with the tools that it supports. The LLM is the one which decides which tool to invoke. Say you call the Glue crawler, it knows that there is a function associated with Glue, it's going to call that. But when you start asking questions on your data set, from the sales data, identify top 10 products. The LLM is aware that, hey, this is a query, so it's going to invoke the function which is associated with Amazon Athena. So again, the best practices integrated with all of this workflow. When you're using Amazon Redshift, which is a data warehousing service, there is Redshift MCP server, and this Redshift MCP server is read-only. It provides you the information. You can say, list all the endpoints in my account, or if you have 2 endpoints and you want to query across those 2 endpoints on customer information, you have the ability to do so, but it's read-only. If you are using DataZone MCP server, where you can list and subscribe, when you are using Amazon Managed Streaming for Apache, think about an admin persona who wants to create a cluster, who wants to set the retention log, who wants to get insight into the resource monitoring. So the MCP server for MSK is more from an admin persona. When you are using OpenSearch, the OpenSearch MCP server, you can list indices, but you can also ask questions on your data set. Again, this is only a small list of the MCP servers and the corresponding natural language questions you can ask. So now, we walked through the theory part. Let's now dive deep into the action and how to make it possible. I'd like to hand over to Ram, but thank you so much for joining us.
Thank you, Harshita, for that amazing overview of the agentic loop and the capabilities of the various analytics MCP servers. Just a quick check. Am I audible? All good? OK. All right. So as a solutions architect, I do help with multiple customers to implement data and AI solutions. When I talk to them, there is one thing that is consistent, one requirement that is consistent across all the customers, which is the need for data engineering. And I'm pretty sure we all are here because of that, right? Now, let's see, the any company retail that we were talking about is not any different either, right? So they have the same challenge. Now, let's take a look at how we can implement that solution which will help you to do this data engineering much faster. Here is an architecture that can help you with that. This can actually give you a state-of-the-art data engineering with agentic capabilities that Harshita was mentioning earlier. Now, here if you look at, you can see the various MCP servers coming together to help the task that a data engineer would like to do. There are multiple tasks, whether it's governance, whether it's data processing, whether it's SQL querying. There are multiple things that a data engineer would want to do. So these MCP servers come together to help the data engineer with those tasks. Now, let's take a look at it a bit more in detail. Let's start from the left. So here the user is interacting with the MCP host, the one that Harshita was mentioning earlier. And that MCP host could be any tool of your choice. It could be SageMaker Unified Studio, or Kiro, or Cloud Desktop, any of those MCP compliant MCP host. Now, once you have an MCP host, the next thing that you do is you configure whatever MCP servers that you want to work with. When you configure that, it makes a connection between the host and the server using the MCP client. Now, the intelligence part of this whole agent lies below, which is the large language model. And in this case, we are using Amazon Bedrock's large language models. Now, when the user asks a question, hey, this is a task that I want to do, LLM interprets what is the user looking for, and LLM also understands through MCP host and the client, it also understands that these are all the tools that I have at my disposal, and how can I best deliver the result to the user. Now, if you remember what Harshita was mentioning earlier, there is always a loop, or it's an iterative process, because we may not get the answer right at the first one, because there are multiple steps involved in the task. So what LLM does is it uses the first tool, get the data, or do the first task, get the result, and then identify what is the next tool which can solve or continue solving the problem that user has asked. And that iterative process finally takes you to the final result, what you want to get to. Now, let's take a look at how we can configure MCP server in some of the tools so that you can get going with some of these activities. So here is a screenshot of how you would do this in SageMaker Unified Studio. If you're familiar with SageMaker Unified Studio, this is the notebook experience there. On the left-hand side, you will see the Amazon Q icon. And once you click on that, there is a tool icon on the top of the right corner. Once you click on that, that will give you a pop-up to give the details about the MCP servers that you want to configure. All what you need to do is provide the name of the MCP server and a couple of configurations, and you are done. Now, in this particular case, I'm configuring data processing MCP server. With this simple step, now you have the capability to interact with your various data processing services in natural language. Now, let's take a look at how you would do the same thing in case of another tool, Kiro. So it's not any different, just that in case of Kiro, there's a mcp.json file. All what you would do is you have a block of JSON configuration that you need to add for each MCP server that you want to bring in. So you might be bringing in Redshift MCP server, or Data Zone MCP server, or Data Processing MCP server. For each one of those MCP server, you will have a JSON block that you need to add. And you might see some of the auto-approve list and things like that. We will cover that later in the session. But this is how easy that you can go and configure the MCP in your MCP host client that you have, MCP host application that you have. Now, let's get a bit more specific into the task that we have at hand for any company retail. Let's meet Alex, the data engineering agent. Now, Harshita mentioned the task that we have for any company. We want the help of Alex. We want to start with data discovery. And we want to make sure that Alex is able to go and find out where is the customer data, the customer behavior and customer dimension data files. And then we want Alex to go and create an ETL job. And in that job, the activity that we want Alex to perform is join the two data sets based on customer ID and aggregate the data based on state. And once that is done, of course, we created the job. We want Alex to go and run that job. And it's not just about running. We want Alex to help us with monitoring the job and fix any issues if there is anything coming up. And then we want to catalog the output. After cataloging, we want to do some data validation, because at the end of the day, anything that we do need to be validated. So we need to do some data validation. And once everything is done, if you remember, the marketing team, the execs are really looking for the data in their data warehouse. So we want the data to be loaded to data warehouse. So this is what the data engineering team at any company retail has at hand. This is the task. So let's take a look. As a first step, we'll take a look at how to configure the MCP server in one of the tools like Kiro. So I'm in Kiro, and this is the lighter theme of Kiro. Typically, you might have seen the darker theme there. So here I have configured multiple MCP servers, data processing, Redshift, and you will see the various tools that are listed. And you can also see that other MCP servers that I have configured, you can either enable or disable using a right click. Now, once you click on that little icon over there, that's what will open up that JSON file. So it's a matter of just adding that little block of JSON configuration so that you can add any MCP server that you want to bring in. So that's the data processing MCP server, and here you have S3 MCP server. Here is the Redshift one. So these are MCP servers that I've configured. It's a matter of adding that particular block. Once you are done, that's it. That's all the configuration that you need to do. You are good to go and work with these services using natural language. Now, this is the prompt that we are giving to Alex. And let's not worry about all the things that are written there. But the major things are, hey, Alex, you are a data engineering agent, and we need your help in identifying the data set and processing the data. But one thing, here, human in loop is important. So after every step, come and ask me if whatever was done in the previous step looks fine so that you can move forward. So that's a confirmation that I'm expecting. So we are asking Alex to come back and ask, and then move forward with the 6 steps that we just looked at. I want to go ahead and find the data, then create a glue job, and there we are becoming very specific this time. We want to join based on customer ID, and I want to get the sum of page views and total purchase amount, and land the data set in Parquet. And of course, the aggregation is based on the state, right? And then for run the job, fix any errors, and monitor the job. Then go ahead and create a crawler so that we can catalog them. We can very well put that in the same step itself, in the job creation itself or job execution itself. Now, next one is validating the data using running the queries. And then finally, this time we want Alex to create a notebook so that we can use that to load the data into Redshift. This is a task at hand. Now, let's move to our step 1. So here, we are asking Alex, hey, can you please, these are all the steps that are involved, right? So, hey, you are a data engineering agent. These are all the 6 steps that we want you to go ahead and run, but make sure that come and ask me after each step. Now, let's take a look. You can see that the very first thing that it is doing is it's picking up an MCP tool to list the S3 buckets. And it is going and analyzing the data that is there in S3, because, again, in this particular case, we have specifically said that, hey, go and get the data from that is sitting in S3. Now, in your case, the data might be sitting in, it could be in Redshift, it could be in other places, or the data might be cataloged in a data catalog. So you can use the respective MCP servers help to go and scan for the data, find where it is, and get that specific data. So it is able to find the data, but it is still trying to do something. You know why? Because we have asked in the next step, you need to go and join these data sets based on customer ID and go and do the sum of page views and amount and things like that. So even though it is able to find the data set, it is still going and verifying, hey, do I have those fields in there? Because if I don't have those fields, I cannot really move on to the next step. So it is thinking ahead and making sure that those fields are available. So it is able to find the customer ID, customer name, city, state, all of those details. So there you go. Step 1 is complete. So you have the data sets, this is where it is, and then you have the customer ID, product ID, page views, all of those details. All good. Hey, I'm done with step 1. Can I proceed to step 2? So cool. Data discovery is done. Let's move to step 2. Let's say yes. Proceed to step 2. Okay. So this time, the expectation is Alex will help us creating a glue job. Now, to create a glue job, first and foremost, if you look at the first activity that it is trying to do is using another MCP tool there to get the roles. What that really means is Alex knows that if it has to create a job, it needs to understand that what is a role that should be used with that job, because the role should have access to the right resources, right? So it should have access to the S3 data sets, it should have access to the glue job, glue resources, all of those things. So it is able to get all the data, and it went ahead and created a job, a .py file. So you can see the .py file. In a real world scenario, we should ideally validate some of these things before allowing it to run. So let's assume that Alex is fine here, right? Now it is asking, hey, can I go and upload this to S3? And we will talk about why it is asking us, hey, can I go and upload this? Some of them, it went ahead and did that, but some of the tools, it is coming and asking, hey, can I do this, right? We'll talk about that a little bit later. So here you can see that, yes, it is using another operation, which is create job. So it went ahead and created the job, all good. So looks like the job creation is complete, step 2 is done. So we have it's making sure that there is a get job to see whether the job creation went successful. All good. So we have the job ready. Now we can move on to step 3. So looks like job creation is done. Let's get to step 3. So this time, what we are hoping for is Alex will go and run this job and monitor it and fix any errors if there is anything, right? So this time it called another tool, which is manage AWS glue jobs, and this time it is starting the job run. So again, think about the way we would work, right? So it is thinking ahead, and it is also going that step-by-step process that we as data engineers would have done, and giving us the assistance of what we would want to do. So since it started running the job, let's get to the glue console just to see how things are happening. So let's go to glue console, Mr. ETL, and runs. So you can see that the job is running now, right? So looks like it's happening. And if you remember, what we have told us, it's not just about running the job and leaving it out there. As a data engineer, the agent, you want to go ahead and monitor it. So you can see that it is trying to monitor the job, and it found that there is a sleep time of, it's still running, so it put a sleep time of 30 seconds. Now think about it. As an end user, what you may want to do is, see, you may know that, hey, this job may take 1 hour. You don't want the agent to go and monitor it every 30 seconds, right? So that is something, that is where human in the loop is again important here. So you can guide the agent what to do, what not to do. So you can say that, hey, go and monitor the job after 5 minutes. But this is a smaller data set, so we let that happen. So okay, go ahead and check every 30 seconds. So that's okay. Now we can see that, hey, the job was done, but it is able to, if you remember, we told that, hey, go and check if there are any errors and fix it, right? So it found some error in the logs, and it is going and checking, hey, is there anything concerning? So it went and checked and found that no, there was an error that was fixed. So it moved forward. So it is again going back and validating, hey, is everything good? So it did a list job run once again to make sure that everything is fine. Looks like it succeeded, and it took around 83 seconds, and this is what is the result. So we have the output saved in a Parquet format. Perfect. So our the task for data aggregation is done. Now let's move on to our next one, which is cataloging it, right? So this time we want Alex to help us with cataloging this data set. So for that, we are asking, hey, Alex, go ahead and create a crawler and catalog it. So this time it is using the MCP tool, manage AWS glue databases, to find out which glue database it can catalog that metadata. And once it finds that metadata, the next thing that it is doing is manage glue crawler and creating a crawler. So here you can see that it went ahead and created a crawler, and it even started that. So think about how fast it is going, right? So we would have clicked through multiple screens, created the crawler, started the run. By the time we explain what it is able to do, you can see that in action. You can already see that the crawler is running. So that is what is a productivity improvement that we can gain from these agents. So here you can see that the crawler is running, Now, if you remember, we told in the previous step that, hey, monitor my job, right? We did not specify anything when it comes to the glue crawler. We did not specify anything about monitoring. But it understands that whether it's a job that is running for data processing or a crawler that is running for cataloging, it's all the same. The intent is same, right? So it is trying to monitor by itself and giving us an idea, hey, is it running fine? So you can see that there are some sleep commands and all of those things that it is putting, and it is validating that, hey, is it running? So you can see that now the crawler is in the stopping state. So it's validating again to see another 15 seconds to see if it got executed, if it is complete. So think about the time that we would have spent in a lot of these activities. And what if you are going into an important meeting, starting this pipeline, coming back and seeing the results, right? So a lot of these things can be done by the time you come back. So here you can see that, yes, the task is complete. So you can see the new crawler that got created, and this is the database, and that's the table that's cataloged. That's great. So let's move on. So we have our data cataloging done. Next comes the validation. So we are requesting Alex, hey Alex, can you help us? Okay. Alex, can you help us validate this data? And this time we are just saying validate by running queries. We did not say what query, which service to use. But this is where the intelligence comes into picture, right? So the LLM has an idea which there are multiple tools that are available. We have configured Redshift, we have configured data processing MCP servers. So all of these tools are available. Now LLM is able to decide that, hey, for me to go and do this quick validation for the data that is sitting in S3, Athena seems to be a better choice. So it used that Athena query MCP tool in data processing and went ahead and validated the data. Now, as a data engineer, if we were asked to validate, would we just go with one query, or we would validate that from various angles? We would validate that from multiple angles to make sure that our data is good to go, right? That's exactly what Alex is also doing. So it is trying to validate the data from multiple angles so that we don't have any challenges in the data that is getting created for the next step. So looks like all the validations are done, and it gives a good amount of stats as well. So it has various the states, and it is also making sure that all 50 states are, the data from all 50 states are there. This is what is the total page views, this is what is the total amount. So it gives a quick validation of what can be done and making sure that the data is fine. Cool. So let's move on to the next one. So the data validation is complete. Our final step is to go and load this data into our Redshift. So for that, we're asking Alex, hey, can you go and load this to Redshift, or create a notebook to load this to Redshift? So here, you see that at this point in time, it immediately used a Redshift MCP server. Until now, it has been using other MCP servers. The moment we said, hey, I want to load this data into Redshift, it used a Redshift MCP server to list the clusters. So it is identifying which cluster, because our prompt says, go and load this to analytics Redshift cluster. So it identified the cluster, and it is creating a notebook with all the various steps that are involved. And you will be able to see the notebook that is getting created right away in the Kiro IDE itself. Now, think about the real challenge that we have. I think when Harshita was mentioning about the company that the challenge that any company had, one of the challenges were documentation, right? And we all face, we all love to code, we all love to build the data pipelines, but we all struggle a bit to document it well, right? And that's a challenge that we all have. And that becomes even more challenging when we acquire a set of data pipelines, or we transition over to another team and having to know what is being done. So if you look at this one, you see a very detailed notebook that has a step-by-step process on how to load, how to make the connection, what is the step to load, validate the data, all of those details, and some cleanup at the end. And on the left-hand side, you can also see a README file, so that it, by default, create a documentation for you, so that can be passed on to any other team member who is coming into your team. So It's creating that the README file at this point in time. So that is how you can use these agents in your day-to-day work when you do data engineering. Now, with all of these things, so we can say that, all right, so Alex is able to help us with each one of the activities that we have asked Alex to do. Now, in this whole process, any company has had some good learnings as well, right? So let's talk about that. Let's talk about some of those things. One thing that you may want to keep in mind is we talked about configuring multiple services, multiple servers, MCP servers, right? Now, each one of these MCP servers come with various tools, and it is the LLM which is deciding which tool to use for a particular task that user is asking the agent to do. Now, how will the LLM decide which tool to pick? It scans through the various tools and identify what is the best one to pick. It is always good to, if you are a data engineer, you have the control to configure, enable or disable the various MCP servers. It is strongly recommended to work with the MCP servers or the number of tools that you feel that would be more relevant. Because if you have hundreds and thousands of tools that are listed, your LLM will have to scan through that and figure out what is the best one to use. So you are putting a little bit more work on the LLM. So you may want to, as a data engineer, you might have a good idea. These are all the MCP servers that I want to use. So stick to the tools that you want to use. That's one thing. And it's pretty easy to do that in each one of these IDEs. For example, SageMaker Unified Studio, you can either add or delete a MCP server with a couple of clicks. In case of Kiro, we saw that it's a right click and enable, disable. You can go and do that. OpenSearch has a very interesting way of doing that. There's a tool filter that you can provide. You can say that, hey, I want to have MCP servers loaded only for this particular category, only or this specific task. So you can be very specific in the list of tools that are getting loaded. So something that you may want to keep in mind. The next one is on the protection of your data and the infrastructure, right? So each one of the MCP servers has some good levers that you must be aware of. And that's something that we highly recommend you all to be aware of. For example, data processing MCP server, by default, it doesn't allow you to go and create some of the resources or write the data back and things like that. It is designed like that. So you can go and put allow write to make sure that your MCP server is able to do those activities. Whereas in case of Redshift MCP server, it's a read-only mode. So it is intended to consume the data from Redshift at this point in time. And same is the case with OpenSearch. It is intended to consume the data from OpenSearch. When it comes to MSK MCP server, the persona is slightly different because that's a control plane more than the data plane. The MSK MCP server is more for a control plane. It is for an admin persona. For example, creating a cluster or changing the cluster configuration and things like that. That's why the modifications are by default on in case of MSK cluster. But you have an option to go ahead and turn that off. So please be aware, for each one of these MCP server, there are some good levers that you can use to protect your data and infrastructure. So please make use of that. And the next one is trusting the tools. And this is what I was mentioning earlier. So you might have noticed that in some cases, the agent was asking, hey, can I go and run this one? In some cases, it went ahead and executed those tools. Why did that happen? That is because I have trusted some of the tools. For example, let's say I want to run a query. If it is going against my production database, I want to see that first. Or if I'm uploading something to my S3 bucket, I want to see what is getting uploaded. So it depends on what is your comfort level, which environment you are working on, right? So depending on what are the tools that you feel comfortable that it can go and the agent can directly go and run versus something that you want a confirmation from your side, you can configure those in these various tools. The left-hand side is SageMaker Unified Studio. So you can say that, hey, for this particular tool, ask me or always allow. In case of Kiro, that's where that block comes into picture, where you can put a list of auto-approve tools so that it will automatically be executed if the LLM decides to make use of that tool. Now, with all of that, no matter what, human in loop is important. We cannot emphasize this enough, right? So please understand that the agent is there to help, and consider agent as a peer programmer, right? The human in the loop is important, whether it's read versus write decisions, or what tool is being used, or even the code that it is getting generated, or the query that it is getting generated. You may want to validate that. And also, MCP servers do have options to prevent some of these runaway queries and things like that, but human in the loop is important there as well. So please keep that in mind. With all that said, we have looked at all of these pillars where we see that context switching, data quality, error handling, resource management, best practices, the pillars that any company data engineers mentioned, the pillars of loss of productivity, that's been very well addressed. We're not saying that all of these things will be gone, but it will be improved or it will be reduced. These productivity losses will be reduced with agentic capabilities. Now, that decision, here are some of the results from any company. So it is saving a lot of time for sure. It is productive, and it is easy to use, very simple options to configure, right? And at the end of the day, yes, it is safe. There are good number of levers to keep everything safe. Now, yes, it's really good to have a nice POC and pilot. How will we scale it? In case of a data engineering, it's not really about taking it to production. Rather, it is about scaling it and making sure that there's a scalable option out there. How will you deploy these, right? So if you are just starting with agentic data engineering, I would strongly recommend you to get to SageMaker Unified Studio notebooks and try out the new feature that was released, which is a data agent. So here, you have an agentic AI assistance agent that is inbuilt in SageMaker Unified Studio, which can discover the data, which can create the various steps that is involved for the activities that you want to do, to generate the SQLs or Python code, or troubleshooting any of the errors that you are getting into. Pretty much whatever we just saw, what Alex was doing. That's already inbuilt in SageMaker Unified Studio, so please try that out. Now, there are a lot of customers who would want to have a lot more control and lever. For example, hey, I have a third-party service or third-party data source, and how do I connect to that? That is where this architecture that we looked at earlier comes into picture. So it's not just about the MCP servers that are listed here. Depending on the various data sources that you want to connect, you can bring any of these MCP servers. Now, if you have, let's say, a 10-member team, it is very much okay to have each one of your developers have the respective, let's say all of them are using Kiro, them going and configuring that mcp.json and working with these MCP servers. It could be the same set of MCP servers, it could be different set of MCP servers. That's perfectly fine. That's a widely accepted pattern. Now, there are cases where you may want to have an agent deployed and roll it out to the whole organization. How would you do that? That's where Agent Core, Bedrock Agent Core comes into picture. And in this session, we will not be doing a deep dive on Agent Core per se, but just to give you an example or give you a little bit more details. So here, Bedrock Agent Core has multiple components to it. The runtime helps you to deploy an agent, and the one on the left-hand side, which is the Agent Core memory, helps you to keep track of the conversations that you're having. So that's what this Agent Core memory does. Similarly, if you are working with an agent, we may want to know everything that is happening, so traceability is important. So that's where the observability comes into picture, right? Agent Core observability will give you those details, and Agent Core identity will help you to do the user authentication. Now, gateway, the crux of it is we talked about the various MCP servers. Now you have an option to go ahead and configure various MCP servers using gateway so that when the LLM gets a request from the user, it can go to gateway, find out of the whole list of tools, what is the tool that it wants to use for the next best action. So this is an architecture, and you can see other tools that are getting added to the gateway as well. So you may have some custom tools that you have built in your organization, which you want to bring in as well. So Agent Core Gateway helps you to do that as well. So this is an architecture that you can use if you want to scale it out, or if you have a very specific agent, let's say data analysis agent or data engineering agent that you want to bring or deploy and roll it out to your entire organization. Now, with all that said, going back to Sarah, our CTO, she feels that yes, everything looks good, the pilot went very well, the results are good, and at the same time, she clearly sees a path forward to deploy this at scale. And the recommendation was to move forward and fully roll out the agentic capability to all the work streams. Now, we really hope that you will be able to take these learnings and implement some of these things in your day-to-day activities in your organization. And we want to leave you with some resources. Here are some of the resources. The first one is on the list of MCP servers. We have a couple of blogs on data processing and Redshift MCP blogs. And the one on the bottom left is the data agent, the SageMaker Unified Studio AI agent. And we have a QR code for the agent core as well. Cool. And at Amazon, we strongly feel that we should always keep learning and be curious. And here is a way to learn more about agents. Hope you'll be able to learn more about agents as well. And thank you. And please share what you thought about the session. Please fill in your survey because we really care about that. And we'll be around to talk to you on any questions that you may have. Because it's a silent session, we may not be able to take the live questions, but we'll be around to talk to you. Right, thank you.